We're going to do exponents today. Joey, would you slide your desk over a little bit so you're not so close to Jake? That was more, not a little bit. That was the micro bit. Come on, over here. Don't make me do it. I've had surgery. I'm not allowed to. Okay. Shh. Students will understand what an exponent is. When you do these problems, put that away, Luke. You will be looking for, if you understand what an exponent is, it's easy then. Okay, Chris? We're going to multiply and divide expressions with exponents. I don't think we're dividing today. I think we're just multiplying. Let's cross divide out. And we're going to simplify expressions using the power rule for exponents. That's our plan for today. You have seen this before. The problem is you tend to get thinking, well, I did this last year, and you're going to do it wrong. So pay attention and understand what's happening, because if you understand, you remember. When you write this out as a product, oh, before I do that, that's called expanded form. Before I do that, though, let's talk about what does 3 times 2 mean, and what does 3 squared mean? Yeah, what does it mean? 3 times 2 means either 2 plus 2 plus 2, 2 added up 3 times, or 3 added up twice. So the number in front here, if you want to think of it as a coefficient, is repeated addition. Okay, Jen, please don't do that. Okay, Nicole, your iPad should be down. Katie, your iPad down. Matt, put that away. Okay, what does 3 squared mean? 3 times 3. It's repeated multiplication. So when you see 3x, that means, if you know this, then you're set to go, but I'm not sure you do. It means x plus x plus x. X added up 3 times. That's what it means. Okay, Luke? If I have x cubed, that means x times x times x. It's repeated multiplication for an exponent. So an exponent means repeated multiplication. And the number you multiply out all the time is called, starts with a B. No, good job, Joey. This is this one. This is the coefficient. And that's the base. Let's go. Okay, we're going to do exponents, and we'll do some exponential growth eventually. You don't have that written down. You should really write it down. Here's the problem, and I saw it in my other class, is they go, yeah, we know this, and they get to the homework, and they don't know how to do it. Because they don't know what it means. So you don't know it as well as you think you do. That'll work too. You should have it written down too. No, you need your notes. We can't turn your notes in. Okay, when I write out the repeated multiplication, Joey, that's called expanded form. How do I write that? X to the what? 4th. And there it is. This we call simplified form. I don't know if it's really, well, it's simpler. Why do we have exponents like this, Jans? To simplify our life. Because if I see 10 multiplied by itself 20 times, I don't want to see 10 times 10 20 times. I write 10 to the 20th. And we do this all the time in science class with our scientific notation. Yeah, well, it's all exponents. So you're going to, and this is easy to start. What's x cubed expanded? Okay, so you're going to be given problems where they're expanded, you simplify it. What about this one? Y times y, and then x times itself 4 times. Whoops, supposed to be an x. I just do a dot. Here, I don't have to. There is a dot there. You don't really have to put the dots in them. That's always assumed. Although you have to be careful if you have a TI-inspired calculator. If you don't put the dots in there, that's a word to the calculator. Okay, now, this is more complicated. Let's look at the outer exponent. This is the part that people had problems with. This means 2a squared c to the 5th. How many times? Okay, this is going to be painful to write out the expanded form. Well, you're not going to do much of that. And then let's write out what it means. We're still not expanded. 2a squared is 2 times a, and c, 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 c. See, I'm not even putting the dots in there. Who cares? Yep, sorry. That's the first one. The second one is 2, and then I have a times a, c, 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 c. Okay, a lot of you like to forget about the 2 and say, well, that's not being cubed. Put 3. That means I've got this 3 times. Okay, let's do the last one. 2, a, so we're going to do 1, 2, 3, 4, 5. I got it in there. And if I want to simplify it, I'm just going to add them all up. No, not this bad. Okay, it's first. But no, these are, now here's the deal. It's not addition. It's all multiplication. Nope, because it's not 6. What is 2 times 2 times 2? No, what's 2 times 2? 4 times 2 again is 8. So that's 8. And I can't multiply the a's out. All I can do is simplify it by, whoops, I don't want a there twice, is by counting up how many a's are multiplied. How many a's are multiplied? Let's see, I got 1, 2, 3, 4, 5, 6. How many c's are multiplied? Put your phone away, please. I got 5 here. 5 and 5 is 10 and 5 is 15. Do you know what I'm doing with the exponents? Am I adding or multiplying? I'm adding. Okay, have a seat, please. Now, we're going to learn how to do shortcuts. We don't want to do this every time, do we? Yeah? We don't want to have to write that out. That's too much of a pain. So we have to learn some shortcuts. Okay, let's do this one. You guys try it. I don't know. Jake, what did you get? 8/3 c squared. Some of you don't like the fact that there's no numbers there, but there are numbers there. It's 1. Max, what about this one? Just 3. How many x's? That's all it is. The exponent is counting how many times you multiply. Okay, Joey? This one's just a little trickier to see, I think. Okay. Let's see, I got a J, J, and J. That's 3. You could, but that's not what we want. We want it simplified. How about K? K's. That's 3. How about L? 1, 2, 3. Could you write it this way? This is what Jens is asking. Yes, but it really is what we want is this. Not really. About the same. These are equal. If I have JKL cubed, is K cubed here? Joey? No. If I want the J and the K to be to the 3rd power, I must put it in parentheses. We're going to get to that. JKL with a 3 on it is not equal to that. Exponents operate, unless you have parentheses, China, exponents operate on the number right next to it. Jens, move back to chair, please. Okay? Where are you moving to? Okay. Now let me say this again so I can get this clear. Okay, guys? The 3 here only operates on what it's next to. It won't operate on the K, won't operate on the J unless you have the parentheses. And I don't think I made that clear in my other class. So if I have 2x cubed, that means 2, and then how many x's? How many x's multiplied? 3. Yeah, I'm not saying this is exciting, but it's what you have to do to learn exponents. Okay. Do you know what the rule is? What do you do with the exponents? What if you have x squared times x cubed? Or, sure, x squared is x times x. What's x cubed? X times x times x. How many x's are there? 5. What am I doing with these exponents? Adding them. It's going to get confusing because we're going to do the power rule in a second. What if I have x times x squared? Sometimes this board does weird things. Let's write out what it means. It's x times x times x, so it's x to the what? Third. Okay, some of you will look at that and want to say it's x squared. How many x's do you see here? I see 2 there, 1 here. Add 1 and 2, you get 3. So you add the exponents when multiplying. Think of it as one step below. You have adding, then you have multiplying, and then you have exponents. When you're multiplying with the same base, just drop it down. You add the exponents. When I do powers, which is an exponent, one step underneath that is multiplying. Okay, so try these. I didn't get 5. This one's 5. X squared times x cubed. You just add these little guys. 2 and 3 is 5. Are you ahead? Oh, that's just, you just add these. N plus m. You just add the exponents. I put it in English here. You just add them. I'm not sure. I don't understand what your question is. You don't. If this is what you have, it's x to the n plus m. And if you ever get into some of the higher level classes, you will run into that, where they're letters. So if I have 2 to the 2x times 2 to the 3x, well, all we're going to do is add those, so it's 2 to the what? 5x. I don't know what x is, though. That's okay. So you just leave it, n plus m, because I can't do it. Well, let's do some problems. Like right here. That's just the rule. So what's the rule here? You're going to add the exponents. This part's easy till I add the next part. This is x to the what? 10. Okay. Now we have a little bit of trickiness. How many a's? Because I've got 2 here and 1 there. Put the 1 in if you need to see it. When I used to teach this, I made the students put the 1 in because they would want to say a squared. But it's a cubed. Now all we're going to do is add the exponents. So, what'd you say, Chris? B to the 4th. You be careful. 4b, when you tell me that, I interpret it this way. Oh, 4b's. Yes, okay. Can't quite hear that clearly. But just add these. 7 minus 3 is 4. Try the next one. It's all multiplication. We don't need those parentheses. They just put them there, that's all. Will I ever see anything like this in the real world? Nope. But the property of exponents, you will use that. I have x squared and x to the 4th, so it's x to the what? Now for the tricky one, how about the y's? Good. You got that, Lexi? Good. It's y to the 4th. Oh, I guess the z's are tricky too. Excellent, Kate. Negative 4 plus 1 is z to the negative 3. Oh no, we're going to do the power rule next. That's the one that's tricky. This was, if I multiply with the same base, I add the exponents. If I take something to an exponent, then I will multiply the exponents. So let me give you an example, because that's kind of vague looking, I think. What if I have x squared cubed? Let's write out what it means, and then I won't forget. Okay, powers? This is x to the 2nd, how many times? 3 times. And then I would add these exponents, because that's what we did. If they're multiplying, that's a power. It's x to the 6th. So all you do is multiply the exponents. X squared to cube. Yeah, I just gave you an example. So all you do is multiply these numbers. N and M are numbers. That's it. Pardon? Yes, but do you recognize it's not a multiplication problem anymore. It's an exponential problem. That's not even the right word. It's a problem with exponents. What is the operation just underneath the exponents? Multiplication. If I'm multiplying, the operation underneath multiplication is addition. Okay, so what if I have this? 2a, let's just keep the number small, to the 3rd. Nope. Write it out. It's 2a times 2a times 2a. So it's 2 to the what? Third. A to the third. So it's 8a cubed. You tend to want to, I've taught this for so many years, you want to not distribute that. You do the 3 times the 1, you're okay with that. But for some reason you think a number, a constant is different than a, but it's exactly the same. Okay, Jen? A could be 2, I don't know what it is. A and 2 are just numbers. Okay, let's try some hard problems. And I think then that's it. Then we go to the worksheet. First problem's easy. Yeah. Second problem is the harder one. Let's skip to the third one because the second one is harder. I think I might drag it around because I can. What'd you get for the first problem? Y to the 12. This one's not bad, but don't forget the 2. And what I tell students is put a 1 in there. And the 2 is a little taller than the letters, so you think it's different, but it's not different. Okay? You're going to distribute. This is distributive property of exponents over multiplication. Can't do it over addition. If there's plus signs in there, can't do it. So, but they're not. They're multiplying. So we're going to go 2 to the what now? Third. That's the one that's always missed. And I'm trying to avoid that, but I don't know if I'm going to make it. This is x to the what? 12. Multiply, because it's y to the 8th 3 times. So we multiply, because times mean multiplies, so that's 24. And it's z to the negative 9. Way easier than this next problem. And by the way, that would be an 8. When you do this, you still have to follow order of operations. We have to square this first and then multiply by that. That's what makes it hard. So I'm going to leave this one. You guys don't want to write it down again, but you get all confused when you don't. Plus, you make math statements that are not correct. Okay. Now, let's do this one. What's x going to be? To the what power? X squared. Y to the what? 8th. Jake's with me. Z to the 10th. Now it's just a multiplication problem. So when you get the mixed, where you have a power and a multiplication problem, you got to take care of your power first and then your multiplication. So let's see, what's that going to end up being? How many x's will there be? I'm going to slide that up a little. Kate says 4. How about y's? Max, what are the y's going to be? I have a negative 3 and a positive 8. So it's y to the what? 5th. And the z's, I've got 10. And don't forget that guy. There's 11. Those who say 10, what about him? I think that's it. Not positive, but I'm pretty sure. Yeah. So on Monday, you're going to do the dividing. Mr. Winterhalter will teach you the dividing. And I should be back on Tuesday. At least that's my plan. But I don't know. I wish I knew. I know you guys want to know too. Now, where is that one guy? Okay, it's going to do over here. So I'll get you the worksheet. On the back side is addition problems because you have a cumulative test coming up. I know you didn't want to know that, did you?